Listen to me, everyone. Here, now I am going to discuss with you all the cases for magnetic effect of current. Okay, on the compass needle. Okay, this is a very important topic. So each and everything, everyone must see and listen carefully. Okay, every point. Okay, see on the board I have drawn all the type of cases that can be done. Okay, the first case is this. This is the case when the compass needle and the current carrying wire both are on the same plane, and the compass needle and the current carrying wire both are parallel to each other. Okay, done. And this is the case where the current carrying wire is perpendicular to the plane of the needle of the compass. Done. Okay, now let us discuss these two cases first. Okay, here if I will see, okay, we all know about the right hand thumb rule. Okay, if I apply right hand thumb rule here for this current carrying wire, means assume the current to flow in this direction. Can you see direction? Okay, I will put my hand like this. Thumb is showing the direction of the current. My finger on this side of the conductor is going inside. Inside I am showing with dot. Okay, and for this side my fingers are coming outside. Outside I am showing with a cross. Done. Okay, means the magnetic field is actually like this. Is actually forming a circle like this. Okay, here the magnetic field is going in, and here the magnetic field is coming out. Here the out of the plane. Done. Now, when I will see now only the plane of the magnetic field. Here the plane of the magnetic field is perpendicular with the plane of the needle of the compass. Done. When it is like this, then there will be no deflection in the needle of the compass. Whether the compass is on this side or whether the compass is on this side, there will be no deflection. There will be no deflection because the magnetic field created due to the current carrying wire is actually perpendicular. What is perpendicular? Actually, the plane of the magnetic field is perpendicular with the plane of the needle. Done. So in this case, both the compasses, here there will be no deflection. Now let us go to this here. Okay, here the current carrying wire is like this perpendicular. It is perpendicular with the plane of the needle of the compass. Plane of the needle of the compass. Now here if I apply right hand thumb rule, okay, my thumb will go in direction of the current. Then at this point of junction of the wire and the plane, if I draw the magnetic field, the plane of the magnetic field, okay, the plane of the magnetic field here is parallel with the plane of the needle of the compass. Done. What is the difference? Here the plane of the magnetic field was perpendicular with the plane of the needle. Here the plane of the magnetic field is parallel with the plane of the what? The needle. Now in this case there will be deflection. In this case there will be deflection. Whether the compass is this side or whether the compass is this side. Okay. Now point is in which direction the needle will deflect, means in which direction the needle will move. For this thing we will see what? We will see like this. If I want to see for this compass needle, okay, so at the top, I will see what? The magnetic field is going, the tangent at this point is going in this direction. Okay, that means the direction in which the tangent is going, in the same direction the field will get deflected. Means here initially the needle was like this, now the needle will move like this, and this for this compass the needle will move like this. Clear? Clear? So here there will be deflection, and the deflection of the needle of the compass will be in the direction of the tangent. If you draw the tangent at the tip, if you draw the tangent at the tip and equivalent to this, you are showing the tangent direction like this. You are showing the tangent direction like this. Okay. Now, if you draw the tangent here below this point of the magnetic field, then the tangent direction will be what? In this direction. Okay, means like this, like this. So same, the needle is going like this. Same, the needle is going like this. Simple, very simple it is. Now, the next case. Okay, actually the next case I am discussing because of some confusion that may arise when you read the Oersted experiment. Okay, in the Oersted experiment, what he had said that the current carrying conductor is on one plane, like this, horizontal, and the compass is below the current carrying conductor like this. The compass is here. Now it may look like the first case, that the current carrying conductor and the needle of the compass is parallel, because in the first case also the current carrying conductor and the needle was parallel. Okay, but the difference is there. What is the difference? The difference is that here the plane of the current carrying compass and the plane of the needle are different. This is the plane which is below this plane, or if I keep the needle above the current carrying compass, okay, then this plane is above this plane. Okay, so the needle and the current carrying compass both are parallel. I agree, both are parallel, but the planes are different. Note it, but the planes are different. Okay, now what? Now if I again apply the right hand thumb rule, the arrow, this arrow is actually showing the direction of the current. So according to this, if I put my right hand like this, okay, the thumb is going in the direction of the current, so my fingers are going inside. Means below this wire, if I see any point here, for this point of the compass, the magnetic field is going inside, and for this compass which is above the current carrying conductor, for this point the magnetic field due to this conductor will come outside. Means it will be actually going like this. Okay, it will be actually going like this. Okay, like this. Done. Okay, you can see my fingers. My fingers are coming out of the board, and here if I put, my fingers are going inside the board. Isn't it? And the thumb is fixed in the direction of the current carrying compass. Done. Okay. Now, if I do like this, if I draw a tangent now below a point below. Okay, a point below a tangent. Okay, this tangent actually is according to the direction of the magnetic field. So below, the magnetic field is going in. Okay, so that means the tangent is also going in. Okay. Now that means the magnetic field direction and the needle of the compass both are perpendicular. Okay, both are perpendicular. But the magnetic field direction and the needle, I am telling again, note it, I am telling about the direction. The magnetic field is perpendicular with the plane of the needle of the compass for this point or for this point also. But the direction, means I am talking about the tangent of the magnetic field at this point, it is going in, but in the same plane. Okay, that means the magnetic field direction that is shown by the tangent at this point is in the same plane. Clear? So the tangent here is actually going but in. The tangent here actually is going inside the board. So because of this, there will be deflection, and the deflection will be in the direction of the what? In the direction of the tangent. Here the magnetic field is coming out. The magnetic field plane is perpendicular with the plane of the needle. But the tangent, if I draw is coming out, okay, and that will be the tangent which will show the direction of the magnetic field which is coming out, that will be in the same plane of the needle. Okay, so the magnetic field direction tangent is same plane with the needle but perpendicular. Okay, but here also the deflection will be there in the needle of the compass, and the compass will move in the direction of the tangent, towards the direction of the tangent. Understood? So what is the difference for here and here? Here the magnetic field and the needle both were perpendicular, and the direction of the tangent of the magnetic field for this point and this point, that tangent also was not in the same plane, in the same plane. Here the tangent which was showing the direction of the magnetic field and the needle, all other things are in the same plane. Okay, here the magnetic field due to the current carrying wire, okay, is not in the same plane with the plane of the needle, perpendicular. The magnetic field plane and the plane of the needle are perpendicular, but the tangent which is actually showing the direction of the magnetic field is in the same plane with the plane of the needle. So here there will be deflection, okay, and the direction of the deflection will be in the direction of the tangent. As for this magnetic field, okay, for which at this point the tangent is going inside the board, though the deflection will be what? In the inside the board direction. And here the tangent is coming outside the board. Okay, so the deflection in the direction of the magnetic compass needle will be what? Coming outside the board. Then now this case, okay. Now this case is, before this is one more thing. Now suppose if I consider one point this and one point A and point B, which are on the same plane, So for these two planes, it will be what? It will be similar to this. Okay, if this and this A and B point on both the sides, like this is the conductor, this is one point. Compass position, this is another point, compass. These and these are same. Okay, so here also there will be what? For this point A and point B on the same plane, okay, on the same plane of the current carrying conductor, there will be no deflection. Okay, because why? Because the magnetic field, plane and this plane is what? Perpendicular. Okay, so there will be no deflection. Okay, now let us consider another this case. What? Here this current carrying conductor plane, compass plane, or below the current carrying conductor, the compass plane. All the planes are different. One is above, one is below. Okay, now if I see roughly, the conductor and the needle both are perpendicular to each other. Here the conductor and the needle was parallel but different planes. Here perpendicular but different planes. For this case also, this whole case also, the same thing will happen. Same theory. Okay, what if I draw the magnetic field applying the right hand thumb rule? So what will happen? The magnetic field will be like this. Means in point A, the magnetic field is going in, and for this point B, the magnetic field is going in, and for this point A, the magnetic field is coming out of the plane. Then here, for this plane, the magnetic field plane is perpendicular. So for point A and for point B, if I keep the compasses, there will be no deflection. Okay, done. Now let us talk about this plane, which is below the plane of the current carrying conductor. Okay, the magnetic field is going what? For this plane what? The magnetic field is going in. Okay, the magnetic field is what? Going in. Done? Now see the what I'll say, the twist here. Okay, this is above, this plane is above. Okay, magnetic field is going in like this. magnetic field is going in. So here what will be the thing? Tangent I'll see the tangent. Okay, now tangent, the tangent is going in. Okay, what I told here also for this case and these two, I will see the tangent, means the tangent will show me the direction of the magnetic field. So if I see the tangent is what? Going in. Okay, the tangent is going in. So about the tangent that is going in is in the same plane of the what? Is in the same plane of the this needle. Okay, same plane of the needle. So if the tangent is in the same plane, that means the deflection will be there. The deflection will be there. Here also the deflection will be there. Okay. Now how to find out? What the direction. The direction of the deflection. Okay. How to find out? Here it was simple. The tangent was going in. So in the direction it will go in. Means it is kept like this. So the tangent is going in. Now if I do like this, the tangent here is going in. So it will move in. The deflection of the compass will be going inside. The tip of the compass needle will go inside. Okay. And the tail of the compass needle will come outside. Okay. Here also what? Same thing will happen. Here also what? Same thing will happen. Okay. The tip of the compass needle will go in and the tail will come out. This time the it will happen. Now if you move the compass, both the compasses were exactly below the conductor. Okay, exactly. But if exactly then also it is so perpendicular. The conductor is like this. So the tip is on one side of the conductor and the tail is on other side of the conductor. Isn't it? So the deflection is happening in the same way. Okay, so the deflection is happening in the same way in this both the cases. But here the deflection was not happening in the same way. Why? Because the needle and here the needle is exactly below, here the needle is exactly above, and the needle conductor or this needle and the conductor both were parallel but different planes. Here perpendicular but different planes. So the deflection will be in the same way. Okay, in the same way. So for this compass also the needle will go in the direction of the tangent, means inside. Here also the needle will go in the direction of the tangent, means inside. Okay, the tip of the needle, and the tail will come outside. And according to that, if the current direction changes, obviously the direction of the deflection will also change. Clear? Means main thing is what? Is that you have to consider the plane of the magnetic field or the plane of the tangent drawn in the direction of the magnetic field. That will only clear your confusion. Done? And if you have still any confusion, you can call me. I'll explain more. But I hope this video will clear your doubt. See the video full and it will be cleared.